Owning a boat comes with a number of perks, like being able to say ahoy or land ho and not feel weird about it. So here's another perk. Geico's boat insurance offers access to the largest towing fleet on the water. And with specialist support from agents that are as passionate about boating as you are, there's so much value that you'll want to say, shiver me timbers, and not feel weird about that either. Get more with Geico.
Hello again. Thank you for joining us. This is yet another episode of Space Nuts, the astronomy and space science podcast and radio show on the Community Radio Network in Australia. My name is Andrew Dunkley, your host. And coming up on this episode, a question that we may or may not be able to answer. Did we just find a dark matter star or a dark star, to use the term? We will find out. The oldest impact crater has been found, and it's in Australia. And we're going to update a couple of missions. The Blue Ghost mission, how is it going? And another mission called Athena that isn't going. We'll tell you why. There's been another Starship explosion, and if we've got time, we'll chuck on a success story, because I think we're going to need one after all of that. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And the man of the moment, who's feeling real groovy, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Groovy, baby. Yeah. Just sock it to me and all that stuff.
I've heard that one for a long time.
Well, yeah, like we were talking about in the promo, when you look at me, you're looking straight back to the 1950s.
Oh, gosh. I didn't think light was that slow.
No, it's pretty slow when it comes out here.
Yeah, indeed. Now, we've got a lot on this episode, and the very first story I wanted to tackle was this one about the possible discovery of a dark star. Now, we've had quite a few questions from people asking if they exist and what are they, and we've basically said, well, they might exist. We haven't found one yet, and now the James Webb Space Telescope may well have spied one.
Yes, actually, they might have spied three, because there are three candidates for these dark matter stars. And so, just setting the scene, the story of the universe is that, yes, there was a Big Bang, and took a little while for atoms and things to form, but that all happened. We had a period called the Dark Ages, when the universe was filled with basically cold hydrogen.
And there were nights. Nights.
Yeah, with a K or without a K, whichever way you want it. It's the Dark Ages, before the first stars and galaxies formed. And we think the first stars to form were we've sometimes talked about these, population 3 stars, which are basically completely devoid of anything other than hydrogen and helium in the spectrum, because those two elements were formed in the Big Bang. And we know that all the other elements, actually there's a trace of lithium as well, a couple of other things, but nothing to worry about. All the other elements were formed in the interiors of stars as the universe progressed. So all the stuff we're made of, apart from the hydrogen, was once inside a star. And that's kind of, the story of our origin. It's our creation story in a sense. So what people have been looking for is population 3 stars. They called that for historical reasons, but they're stars that would have been the first stars to form. And they would have been bright. They would have, been much brighter than the sun. But the thinking has been over, I guess, the last maybe 10 years, since we know that more than 3/4 of the matter in the universe is dark matter. It's this stuff that we know exists because it holds galaxies together and stops them flying apart. It's got gravity, doesn't interact in any other way with normal matter. So we believe dark matter originated in the Big Bang as well, like the hydrogen. And so the postulate has always been made by always, I mean within the last decade or so. It's probably actually more recently than that even. It's probably only over the last 5 years. The postulate was, could you have objects which are basically made of clumps of dark matter coming together under their own gravity, like hydrogen does in normal stars. But this stuff clumps together, it compresses because its own gravity is so strong. So you've got this huge lump of dark matter. And what it then does is, and this is still a hypothesis, we believe that dark matter self-annihilates if you get it particles too close together. It's a bit like matter and antimatter. You know, normal matter and antimatter is matter with an opposite electric charge. You bring them together and you get radiation, you get gamma rays. So the thinking is that the same might happen with dark matter. You bring particles of dark matter, they self-annihilate and produce a lot of energy. And maybe perhaps even what's left might act as the nucleus for galaxies to form. But the idea is that these dark stars, and it's a ridiculous name because they're billions of times brighter than the sun, but they're made of dark matter, which is why that name comes, maybe 1 million times its mass. The thinking is that they may have eventually condensed to become the supermassive black holes that we find in the centers of galaxies. And we find them at an age of the universe that was earlier than we can kind of understand. Anyway, there are 3 objects that have been observed by the James Webb Space Telescope, which are formally delineated as galaxies, but they have characteristics in them that have made a number of researchers, and this work is, it's coming from US universities, and in fact, a number of US universities have collaborated on this. But the point about these observations is that whilst they originally were identified as galaxies, because we see them, when the universe was 300 million years old, we're looking back in time, almost the whole age of the universe. They look just like blobs to the Webb telescope. And they look like a lot of the other galaxies, but it's their spectrum that is raising the possibility that these are dark matter stars. And the problem is, we know so little about dark matter that, it's a hypothesis. It's a hypothesis that dark matter self-annihilates. We don't know that for certain. But the deal is that there is enough evidence from the spectra of these objects that makes people think that they are dark matter stars. And I'm going to quote one of the researchers on this topic. It's Dr. Freese, Freese, who has said, and it's a really nice quote, if you've got a dark matter star forming, Dr. Freese says, you've got a weird thing. It looks like the sun in terms of its surface temperature, but it's 1 billion times as bright. It could be as bright as an entire galaxy of fusion-powered stars. That means stars that are powered by hydrogen. And then the thinking is, as I said, that at the end of their lives, they would collapse into supermassive black holes. So this is really quite an extraordinary postulate, but it is gaining traction. And this is not something that's being highlight. Well, it is being highlighted in the slightly more frenetic science press. Dark matter stars found. I mean, this is coming. In fact, the article I'm looking at is from Scientific American, which is one of the most sober and accurate of all the science media feeds. So have a look at that article. JWST might have spotted the first dark matter stars, and if you can make more of it than I can, that's good, because the researchers are still groping with the fact that we know so little about dark matter. And it's one of the co-authors, and Dr. Freese just mentioned, Catherine Freese, who's an astrophysicist at the University of Texas at Austin.
It's fascinating because these are, once again, named very inaccurately. Dark matter, as is dark energy. So let's just make a dark star that's not dark.
I know. It's comical, isn't it?
Yeah, it is a bit. But I think one of the questions that popped out as you were explaining it was these happened very early in the universe, 300 million years after the Big Bang.
Yep.
Does that mean that these may have existed and no longer exist?
I think that's the thinking, that they have a very short life. But the debris becomes the supermassive black hole. And so in a way, these things might form the nucleus of galaxies, baby galaxies that are being formed in the early universe. It's a really exciting prospect. And I hope we'll hear more about this and talk more about it. I know our listeners, Andrew, and our viewers have latched onto this over the last couple of years, because we've had several questions about this already, but it's now sort of bubbling to the surface with these 3 galaxy candidates, which currently they're still thought to be galaxies, but the possibility that they are actually dark matter stars is becoming very, very insistent, if I can put it that way.
I think the original paper published about these 3 potential galaxies was July 2023. But now they've taken another look at them and they're thinking, hang on a minute, this might be some other dark matter. Boom, boom. Anyway, as Fred said, you can look it up at scientificamerican.com. It's a fabulous article. Now, Fred, let's get very close to home for us. Well, not really, because it's in Western Australia, but they've just announced that the oldest impact crater has been found in Western Australia, which basically means in Australia, we have now got the oldest and the largest. They're not the same one. The largest is actually in New South Wales, but the oldest is in that very remote area of Western Australia, around the Pilbara, isn't it?
Yes, it's the Pilbara region. That's right. Sort of northwestern Australia, a very empty part of the country. A bit unforgiving if you happen to be lost there. But our heroes in this story aren't. They're scientists from Curtin University. And what's really nice about this story is that these scientists actually predicted that there might be an impact crater kind of pretty well in the middle of Australia. And what's led them to that conclusion is a sort of alternative view of how continents formed. So the geological thinking around continents, which of course are represented by continental plates, the plate tectonics theory. One, I guess, of perhaps the most popular view is that the continents formed above plumes in the Earth's mantle, which is that sort of soft region between the core, which is deep in the center of the Earth, and the crust, which is the thin layer that surrounds it. So you've got these plumes coming up, and everybody draws the same analogy. It's like a lava lamp, the wax rising. They come up, and they basically, the plume of hot stuff sort of condenses out or solidifies on the underneath of the continental plate, and you get a continental plate. I think there's another one that says that actually it was just plate tectonics. As plates collide with each other, there's often what's called a subduction zone, which is where one plate slides underneath the other. And so the suggestion is that as plates slide underneath the continental plates build and become thicker. And those are the 2 main theories. But these scientists at Curtin, they published an original paper on this several years ago. They suggest that the energy required to make continents actually came from impacts. So, an impact that might be an object that's many, many kilometers in diameter. Remember, the dinosaur killer was about 10 to 15 kilometers. Impacts on the surface, they basically put a huge amount of energy into the surface. You've only to look at one of the simulations of what the dinosaur killing asteroid that created the Chicxulub crater, what that did to the Earth during the first 15 minutes. It sort of just turned the surface into liquid, and you get a big splash. And they suggested that an impact might be enough to basically generate the material that you need to make a continent, maybe more than one collision, but the impact. And I'm going to quote, because there's a lovely article on this written by these authors themselves. It's in the Conversation. It's called Earth's Oldest Impact Crater. It was just found in Australia, exactly where geologists hoped it would be. What they say in that article, and they're talking now about the idea of impacts creating the continental crust. Our evidence, our evidence lay in the chemical composition of tiny crystals of the mineral zircon, about the size of sand grains. So they are generally produced by impacts. But to persuade other geologists, we needed more convincing evidence, preferably something people could see without needing a microscope. So in May 2021, we began the long drive north from Perth for 2 weeks of fieldwork in the Pilbara, where we'll meet up with our partners from the Geological Survey of Western Australia to hunt for the crater. And then they tell the story of what they found. And they found the evidence very, very quickly, within the first hour of being there.
Really?
Yeah. Because what they found was shatter cones. And let me quote again from the article. Shatter cones are beautiful, delicate branching structures not dissimilar to a badminton shuttlecock. They are the only feature of shock visible to the naked eye, and in nature can only form following a meteorite impact. Little more than an hour into our search, we'd found precisely what we were looking for. We'd literally opened the doors of our four-wheel drives and stepped onto the floor of a huge ancient impact crater. And so they've done a lot of subsequent research. They've been back to the site, and yes, they have essentially defined it, I suppose, this as the world's oldest impact crater, which pushes the age of the oldest impact crater back more than 1 billion years, because they say this formed more than 3.5 billion years ago.
Wow. And this is huge, this one.
It is, yes. It's, it's continent-sized almost. So it would have been, by continent, I mean a significant chunk of the Australian continent, which is what they represent by the Pilliga. Mm-hmm. So the Pilliga may be basically the extent of it, which is very, very big.
That is incredible. So how big a rock would create?
Actually, it's a really good point. I think we're talking about several kilometers here. I'm just switching to their original paper on this, which is called a Paleo-Archean Impact Crater in the Pilbara Craton, Western Australia. And I'm just looking to see whether they think whether the abstract... Yes, okay, here we are, 10 to 50 kilometers in diameter.
Whoa.
Yeah. So it's big.
Massive. Yeah, you wouldn't
bigger than Chicxulub.
Yes. We know how damaging that was. So this is quite incredible. They've actually, in the Conversation article, got a photo of one of those
shatter cones. Yeah.
Quite incredible. Now, to the untrained eye, you'd probably just go, "Oh, that's nice."
Move on. You and me both.
Yeah.
But yeah, I mean, it is quite extraordinary. It's really neat if you've got a geologist with you on, some of these expeditions. You start to see things straight away. When we did a tour last year of South Australia, and one of the things we were looking for were the stromatolites, those microbial mats, the evidence for them in the fossil record. Yeah. And they're kind of all around you, but you don't see them. And then we got to a sign that said, "Here's a stromatolite." And, oh, that's what it looks like. And then you see them everywhere. And it would probably be the same with shatter cones.
Yeah, I've had a similar experience. When you're thinking of buying a new car, you haven't bought it yet, you just see them everywhere.
You do. That is absolutely true. That happened to me when I got my last car. Saw them everywhere.
Yeah, that's fun. Funny how that happens. All right, if you'd like to read up on that enormous crater, and I will add, Fred, that finding craters like this on Earth is difficult because so many of them are hidden because Earth's alive and all this gets covered up. And
this one was covered up with
dust, rock.
That's right. It was covered with basalt.
So it sometimes it's looking you in the face and saying, "Here, I'm here."
Yeah.
You can't see it. Yes, theconversation.com is where you'll find that amazing story. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Okay, time for a couple of mission updates. We spoke last week about the successful landing of the Blue Ghost mission, the Firefly probe or whatever it was. See how up to date I am. There's a mission update. This has been going rather well.
It has, yeah. And in fact, you can find on the mission page, the Firefly aerospace mission page, just look fireflyspace.com. They have live updates on how it's doing on their surface operations. Remember, it's only active for one lunar day, or one period of lunar daylight, which is 14 of our days. I think they're on, what are they on now? They landed on...
on
2nd of March, I think. So we're now...
to Orbit Insertion Command, March the 1st.
Yeah. So I think they landed on the 2nd.
On the 2nd, yes.
And so we've got, a succession, day by day, lovely images showing the surface that they landed on. Quite amazing stuff. By March the 6th, they'd completed 8 of their payload objectives. And remember, this is part of NASA's project for putting commercial payloads on the moon to do studies. March the 7th, they had the new lunar magnetotelluric sounder deployment footage. So work that one out. And it's basically the lunar magnetotelluric sounder is on a mast. It's 8 feet tall. And it basically, so magnetotelluric means based Earth magnetism. So they're using the Earth's magnetic field to sample the deep interior of the moon to learn more about the structure and composition of the moon's mantle. And a couple of days ago, March the 8th, that's the latest I've got. I should probably update this, but I won't just now. Planned power cycling for lunar noon. Lunar noon is when the sun is at its highest in the sky.
Yeah, this is one of the problems you're trying to overcome because of the temperatures.
Yes,
on the lunar surface during the lunar day risks sort of cooking.
Exactly.
So they power cycle it to keep it cool, which I think is pretty cool.
It is.
Again. But the latest thing they've done, Fred, is drilling operations.
Okay.
They performed Lister operations mounted below the lower deck, NASA's Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity Lister.
I love it.
It's a pneumatic gas powered drill.
Yep.
Through which was developed by Texas Tech University. So they're doing a lot of work up there. It's really exciting, and so far so good. Everything's worked.
That's correct. Just a quick word of explanation as well. The lunar moon thing is pretty important. A maximum temperature of about 120 Celsius. But this spacecraft landed in Mare Crisium, the Sea of Crises, which is very near the lunar equator. So the sun is going to be very high in the sky. It'll be like being in the tropics here on Earth, which is why that's such a big issue, to keep the lunar noon, everything working properly.
Yeah. If you would like to follow the mission, the Blue Ghost mission, you can go to fireflyspace.com. That's their website. From success to a successful failure, we'll call it. This is a mission that landed in a very different place on the moon, very close to the South Polar region. Unfortunately, and this is the second time that it's happened to this company, the lander fell over.
That's right. So they landed successfully, as they did with another spacecraft about a couple of years ago. A successful landing, but it fell over. That's twice. And it's so sad because a lander that is expected to be seeing the sun and receiving power through its solar panels suddenly finds itself on its side where it can't see the sun, or the solar panels can't. And essentially, the spacecraft dies very rapidly because the batteries don't last very long. I think it's Intuitive Machines is the company that's launched this, and its predecessor, or has built it and deployed it. They did as much as they could in the short time they had before the batteries ran out, but it's now been declared dead. Sadly, it's a very brave attempt. I think I read a comment last week when we were talking about Blue Ghost's successful landing. One of the reasons that they think they were successful, it's probably actually easier to land in Mare Crisium than it is near the South Pole because there's so many mountains and rocks and things near the South Pole. But one of the things that the Firefly Aerospace credited with their success was the fact that their lander has it's a quadrupod. It's 4 legs, which are spread well out, with the spacecraft itself having a low center of gravity. And when you look at the Intuitive Machines spacecraft, you can see it's the opposite. Their landing legs are relatively close together, and it's a tall spacecraft. I think it's 8 meters. I might have that wrong. That's very big, but it's very tall. So you've only got to get a slight, I don't know, maybe even a rebound from the lunar surface at the wrong angle. And what's going to happen? It's going to fall over. And sadly, that's what's happened.
Yep. Their first mission, IM-1, tipped over. And it sort of we had a 4 leg system, but one of the legs broke after it landed on the surface, and it landed heavier than they expected.
Yeah, that will be another.
Yeah, IM-2 was the name of this one, and I'm not sure they've actually figured out what happened as such. But it had so many really great toys on board. It carried 2 small rovers. It carried a hopping robot Grace, which was going to sort of drill for ice. This was not a cheap loss either, $62.5 million. It must be so disappointing. I mean, they got it down on the ground, but something just, and they might have just hit a rock. Who knows? But very, very disappointing for the Athena mission on the moon.
0G, and I feel fine.
Space nuts.
Fred, let's move on to another successful failure, because they keep calling it that. And this is a Starship explosion. Now, we only talked about one last week with all the sky lit up by debris falling back into the atmosphere, and it's happened again.
Yes, that's correct. Starship Flight 8, a bittersweet one, because they successfully brought the Falcon Super Heavy booster back and grabbed it by those chopsticks on the launch pad. That all worked flawlessly. But the spacecraft itself, the Starship, suffered what's it called, a rapid unscheduled disassembly in space.
There's more, which was blamed on an energetic event.
Yes, that's right. An energetic event. I think we call that an explosion, don't we?
I think we do.
Yeah. But it actually, it was a little bit startling because the explosion happened over land, and there was a lot of debris visible. The explosion was photographed by many people.
Oh, yes.
And I think they're probably mostly in Florida. And the debris cloud that was coming back down to Earth was very, very spectacular. There's quite a lot of movie footage on the web that you can find.
There is. And one of the big problems this causes is it creates havoc for domestic air traffic.
Yes.
I think for nearly an hour and a half, flights at 4 airports in Florida had to be halted just in case.
Yep. Miami, Fort Lauderdale, Palm Beach, and Orlando.
Yeah, that's a big worry.
It is. That's right. It is indeed. It's a big worry that you're going to have bits of Starship raining down on your flight. So, yeah, I think they all just kept all their aircraft grounded until the thing had all fallen back to Earth. Yeah. So another, I mean, there have been, if I remember rightly, there've been 2 of these re-entries of the Starship. They haven't tried to put Starship into orbit properly yet, but 2 of the re-entries have been better controlled. One got down to a sort of touchdown speed over the ocean, but the thing then exploded before it hit the water. There's quite a litany of interesting stuff going on with this. Of course, Elon Musk has a huge investment in this, in the success of this vehicle, because he's contracted to land the Artemis astronauts on the moon with the Starship spacecraft. And those astronauts must be looking at these.
And they're thrilling.
Yeah, exactly. They've already been fingered. They know who they are, and if they're watching the TV or anything. Yeah.
Yes. There would have been a lot of beeping on the audio coverage, I imagine. Elon Musk described this one as a minor setback, which he always tends to do, I think.
He does,
yeah. So to that successful failure to a successful success. Now, this is another thing they found in Australia. This is the Varda space capsule, which came back to Earth, and it's the first commercial landing in outback Australia. This was a California company, and I love it because the name of the spacecraft was W2, which stands for Winnebago 2. It was a long, slow mission. But the capsule was launched along with another 130 things on the payload of a SpaceX Falcon 9. And they report it as a ride share mission. So this is Uber in space, but they orbited the planet for 6 weeks, and then the capsule made a plunge back into Earth's atmosphere and landed at the Coniba Test Range in South Australia. And this was a spacecraft that carried a spectrometer from the Air Force Research Labs and the Varda Enhanced Pharmaceutical Reactor, because what they're looking at doing is zero-G manufacturing. This is, so they're very excited. This was a huge success for them. And we wish them well, because there's not much more I can tell you about it.
That's good.
Well, I guess we'll find out more as they further develop it. But what's the advantage of micro G?
Yeah, so I think you can create it's chemistry, pharmacology by the sound of it. You can create bonds between the molecules that behave a little bit differently, I think, from what you do under gravity. And just the structural integrity of things is different in microgravity. So I think there are a lot of experiments being done to see if we can do things, make them better, make them more successful, make them more expensive.
Yes. Yeah. I think as it re-entered the atmosphere, it hit Mark 15.
Yeah, that would. Yes.
He's done quick. Not bad for a Winnebago. Okay. You can read that story at .com. Fred, we are done. Thank you so much.
Great pleasure, Andrew. Always good to chat. Some good stories too.
Yeah. It's a very active episode. If you'd like to catch up on anything Space Nuts related, don't forget our website, spacenutspodcast.com, and you can have a look around while you're there, not only at our past episodes, but some of the program notes, if you're interested in chasing up anything we've talked about, are always there. Hugh's very diligent with that kind of thing. And plenty of other things to see and do on our website. Now, I always thank Hugh in the studio, who couldn't be Hugh in the studio today because apparently he was out taking a walk and came across this little lunar lander and thought, no one's watching. Gave it a shoulder charge, and that was the end of that. And from me, Andrew Dunkley, thanks for your company. We'll see you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.